Okay, hi everyone. So sorry I'm not there today, but that doesn't mean we can't kind of keep rolling with our SOHCAHTOA trigonometry here, okay? So today what we're going to look at are right triangles, but word problems associated with them. And the two word problems we commonly have with right triangles have to deal with angles of elevation and angles of depression, okay? And they're similar, they just have a slight difference, okay? So the angle of elevation is the angle above the horizontal that an observer must look in order to see an object that is higher than the observer. Okay, so angle of elevation. I got laser pointer here. I don't think so. That's okay. But an angle of elevation, here we go, is right here. So if I take a straight line straight along the horizon, and then so you can just stick your arm out in front of you. Everyone, just stick your arm out in front of you right now, and then if you lift it up, that angle is our angle of elevation. So in this example, the person is looking up at an airplane. So the horizontal goes straight out from their eye, straight line out from the eyeball, and then goes up. Okay. The angle of depression, and not depression as in like the mental illness, but more just the depression as in going down. But if it helps you to remember that, like you feel down when you're depressed, the angle of depression goes down. Okay, so the angle of depression is the angle between a horizontal line joining the observer's eye to an object beneath the horizontal line. Okay, so in this case, I have a dog on the ground below the person. So we have a line that goes straight up from the eye, and then the angle of depression goes straight from that horizontal line down to the dog this way. Okay. Uh, so whenever we have these kind of work problems, it's easier to draw a little diagram first, and then we can go from there. Uh, One thing to note is that with angle depression, the angle's right here. A lot of the times we want to draw it right here, but that's wrong. It's right here. That's our angle depression. So angle of elevation, right there. Depression, right there. Okay. Let's get my pen back here. That's not what I wanted to do. Okay, screw up. I don't remember how to do this. Let's just turn off my phone. No, that's not going to work either. There we go. Okay. Okay, so just do me a favor here. Scratch out Peace Tower there and write Skyline Tower. I modified this example to make it more relevant to Niagara Falls, and I forgot to change the name of the tower that we were talking about. Okay, so first just change that to Skyline. So example number one. From a point on the ground 52 meters from the foot of the Skyline Tower, the angle of elevation, so we know that we're talking about elevation here, the angle of elevation to the top of the tower is 72 degrees. I want to find the height of the tower to the nearest meter. So, oops, this is where I set to draw a diagram because it can be pretty abstract. Just think about it like this. But once we draw a diagram, a lot of times it's a lot easier. So it's been a while since I've been to the Skyline Tower, but I think it looks something kind of like this. We have like the kind of window bit looking there, and then it's on the ground here, and then we have an observer, or we have a point on the ground right here. Okay, so the Skyline Tower, hopefully it's perfectly straight with the ground. So if I were to draw a line straight down, it's actually at a 90-degree angle here. And then I'm looking from a point on the ground 52 meters away from the foot of the Skyline Tower. So we'll go from like the middle here. We're always going to assume the middle here. It's 52 meters from here to here. Okay, so that would get me to the base of the Skyline Tower right there. And then if I'm looking at, oop, kind of missed my mark there. So right there is my point. So if I'm looking here, my horizontal is right here. Oh, that's funky. Okay. And the angle goes up this way. And the angle, it says, is 72 degrees. Oh yeah, and I got my 52 meters here. Now I want to find out what is my height here. So from here to here, how high is the Skyline Tower? Okay, so this is how I draw my diagram. I know that it's an angle of elevation, so it's going up from the ground, 72 degrees. I know that this point is 52 meters from the foot of the Skyline Tower. And I know that I'm looking for the height to the nearest meter. Okay, so what I have here is a right angle triangle. Okay, so what I want to do is label the opposite, adjacent, and hypotenuse sides. Okay, so this is my angle here, that's theta. So if that's theta, I know across from the triangle is always going to be my opposite side. And then I know that always across from the 90-degree angle, so that's not a great 90-degree angle symbol there. That would be my hypotenuse. And this would make this side, that's the other side that's adjacent to the angle, my adjacent side. Okay, so I'm looking for the height. So I know that I need to have opposite here. I'm sorry, I'm looking for which trigonomic ratio am I going to use. Okay, so I have an angle. I know that I'm looking for the opposite side. And I also have 52, which is my adjacent side. So which trig ratio has O and A? Well, that would be TOA, which stands for tangent theta is equal to opposite over adjacent. So I can sub in my numbers. I have tan of 72 is equal to H all over 52 meters. And now I need to get H by itself. So remember, H is in the numerator, so I'm not going to do that shortcut where I flip it. I'm just going to bring over the 52. It's dividing here, so it's going to multiply on the right. Okay, and I'm just going to flip the sides that everything's on. I'm just going to rewrite this as H is equal to 52 now times the tangent of 72 degrees. And please remember to make sure to put your calculator into degree modes. So I can type all this into my calculator at once. And to the nearest meter, we should get 160.0395 so on your calculator. So to the nearest meter, that's going to be 160 meters. So the height of the Skyline Tower is 160 meters. And yes, that's accurate. I looked it up when I was making the question. That's why we changed it from Skyline Tower or from Peace Tower to Skyline Tower. Okay. Next example. We have a tow rope pulling a parasailer that's 90 meters long. Okay, so if you've never seen that, a parasailer is someone, it looks like a big parachute that the person has, and then they're holding onto a rope that's connected to a boat, and that kind of pulls them around a lake or the ocean, whatever body of water they're on. So a crew member on the boat estimates that the angle between the tow rope and the horizontal is 40 degrees. I want to find the height of the parasailer to the nearest meter. So let's draw this out. I have a boat here. Well, that's not a good boat. That's still better. So the boat's on the water. And then I have a rope here. that a parasailer is holding on to. And then they have a parachute here as they're flying in the breeze. And then if we were to draw a kind of straight line down, they're going to make a 90-degree angle with the water. Sorry, I didn't draw perfectly on the water there. Is this an angle of elevation or depression? It's not too relevant to this question, but we know that we're on the water and we're looking up at the parasailer, so it would be angle of elevation. And then I know that the angle of elevation, or this angle, is 40 degrees. And now it says the total rope pulling the parasailer is 90 meters long. So which side does that 90 go on? Does it go here, here, or here? Yes, it's the rope, right? So it's actually, the rope is right here connecting the parasailer to the boat. So that's 90 meters there. And I'm looking for the height of the parasailer. Oh, sorry, I forgot to mention last time. I called this H for height because it's talking about height of the CN tower. So again, here I'm going to use H for the side here because I want to find how high up this parasailer is above the water. So again, I have a right angle triangle. My 90-degree angle is here, so that means that the side opposite is my hypotenuse. Whoa, I don't know what popped up there. So 90 meters is my hypotenuse. My angle theta is here. That is my theta. So that means that H, again, is my opposite side, and this side on the bottom is my adjacent. Okay, so I have the hypotenuse. I'm looking for the opposite. Which trig ratio has opposite and hypotenuse? That would be sine, which is equal to the opposite side divided by the hypotenuse. Okay, so sine of 40 degrees is equal to my height, h, all over 90. That's h for height, not h for hypotenuse. That's why I'm writing height for hypotenuse. Again, this is similar to the last one where the variable that I'm looking for is on the top. So I can bring the 90 degrees over, and I'm just going to kind of flip the side that h and everything's going to be on, just to make it read a little nicer. Oh, and back to here. H will be equal to 90 times the sine of 40 degrees. So if you can plug that into the calculator once, we get 57.850 and a bunch of other numbers. But I just want to round this off to the nearest meter. So it'll be 58 meters. Okay, so these two are angles of elevation. Angle of elevation, I find is easier to draw and be able to identify the angle that we're looking at. Angle depression is can be a little bit trickier because remember, we're always looking from the horizontal and then moving down. So if you put your arm straight in front of you and then go down, that angle is the angle of depression. So Juliet is at her balcony 25 meters above the ground. She notices Romeo, who comes towards her castle at an angle of depression. So notice I'm going downwards here of 35 degrees. How far is Romeo from the base of the wall of her castle? And I'm going to round my answer to the nearest tenth of a meter. So let's draw this. We have Juliet up here in her castle. Ooh, I don't know why that changed colors. Okay, so Juliet is up here. There's Juliet. And we'll give her a little rail here so that she doesn't fall off the balcony. And then we have Romeo down here. Okay. And we know that this is 25 meters high. And we're looking from the top of her castle down to Romeo here on the ground. Okay, so we're not looking to like Romeo himself. We're just looking for how far is Romeo from the base of the ground, or from the base of the wall, which would be on the ground from here to here. Okay, so that's going to be my unknown. I can just call it, oops, that's color according to these. From here to here, I can just call that X. Okay, and hopefully Juliet's architect, who made her castle, was good and made a 90-degree angle here. Now, angle depression. We make the triangle, and you're going to want to put 35 degrees in here. But that's not right, okay? Because remember what I just said, that the angle depression starts on the horizon, and then comes down. So what I need to do here for angle depression, for elevation it's easy because I'm already kind of drawing the horizon here and going out from there. But for angle depression, what I want to do is just kind of draw a dotted line out here. So that is my horizontal. And then coming down to here, that is 35 degrees. Okay, so that is my angle depression right there. So I forgot to underline that. There's 35 degrees, and I'm looking for how far is Romeo from the base of the wall. Okay, so 35 is not in my triangle. Okay, I don't have anything in my triangle right now, unfortunately. What I have, I need this angle in here, theta. I don't need that 35. Okay, but I can find out theta because this is a straight line here going straight up. The horizontal is a straight line here. Right here, I also have a right angle. Okay, and right angles are 90 degrees. So if I want to find out what theta is, I can calculate theta by taking 90 degrees, subtracting 35, because if I have 90 degrees from here to here, oops, and then I subtract 35 degrees from that, what's left must be theta. Okay, so theta would be 90 minus 35, which is going to be 55 degrees. Okay, so theta equals 55 degrees. So I wrote it out right there. You don't have to write it out. It's always going to be 90 here from the horizontal to a straight wall going straight up. So if you write 35 here and then 55 in here, that's all I need to know. Okay, but then we need to use the 55 because that's the one actually in the triangle. Now, last thing I want to do is identify opposite adjacent hypotenuse. My hypotenuse is always across from the 90. My angle theta is in the top left up here, so that means that x is on the opposite side of theta, and 25 is adjacent to theta. I'm looking for my opposite. I have an adjacent side. I have O and A, which again will be tan theta, like question 1. Again, I have the opposite over adjacent for tangent. So tan of 55. So that's a bad photo. 55 degrees is equal to x all over 25 meters. And again, these ones have open need to be. I didn't have to use the shortcut trick. I just bring 25 out to the front. So that's same as x is equal to 25. Actually, I have some space for this one. I'll do it out. What I'm doing here is I'm kind of skipping a step. I would have 25 tan of 55 is equal to x. And then what I'm doing is I'm just rewriting it so that my x is on the left. Just because I like it writing it that way. It just seems to flow better as I'm rating it. And let's say 25 times tan 55 is equal to x. I find it easier to say x equals 25 tan 55. Okay, so that's what I was doing up here. I just skipping this step. I was just skipping this middle step here. Okay, I just went from here right to there, which is fine if you want to do that. Or if you leave it as that in-between step and solve for x when x on the right, that's totally fine too. Oh, I didn't do a therefore statement up for this one. Do that quick. Therefore, the parasailer is 58 meters off the above the water. Sail more is 58 meters above the water. Okay, so we plug in 25 times tan 55 into our calculator, you'll get 35.7037, yada, yada, yada. I just need to go to one decimal place here, so it'll be 35.7 meters. It's about 90 feet, or actually close to 100 feet. Romeo's pretty far away. So therefore, Romeo is 35.7 meters away. Okay, and our last example for today. A lighthouse sits at the top of a sheer cliff. The top of the lighthouse is 33 meters above the sea. The angle of depression to sight a small fishing boat at sea is 24 degrees. How far from the base of the cliff is the fishing boat to the nearest meter? Okay, so what I have here is I have a lighthouse. That's a natural lighthouse with a little light there. Okay. I teach math, not art, so this is why my drawings are not great. There's the water, and here is my boat. Oh, that one's a lot better than the photo I drew last time. Okay, so there's my lighthouse and my boat. The lighthouse is 33 meters above the sea. So from here all the way to there is 33 meters. And that sea, we're just going to assume, makes a right angle with the, that cliff makes a right angle with the sea because it's a sheer cliff. And I'm pretty sure that means that drops straight down. Okay, and then I have an angle of depression. So I'm going to draw my line straight out, and then it comes down to the boat. I actually did that pretty well. So it goes from there down. I draw the little arrow there just to show that it's going down for angle of depression, and that is 24 degrees. So it's like a 24 degrees. The arrow is a little better. And I want to find how far away the shipping is the boat from the base of the cliff. So again, I'll just call that X. Okay. So if I'm labeling size, I know already that this is my hypotenuse. But I don't actually have an angle theta yet. I need to find out, or sorry, I can't find out what this angle is because from here to here makes it, last time. That makes a perfect right angle. Right angles are 90 degrees. So if I take 90 minus 24, I'm going to get 66 degrees for theta. Okay. And this one is actually very similar to the last question. Should have made it, should solve for a different variable here, but that's okay. Be nice and easy for you guys. So I have my triangle here. Oops. Trying to write the marks here. My opposite side is x. My adjacent side is 33. And I don't know what my hypotenuse is, but I don't really need my hypotenuse in this specific example. All I need is O and A because I am using TOA or tangent. Theta equals opposite divided by adjacent. So tan 66 degrees is equal to x all over 33. Bring over the 33, I'm going to put in front. And remember, I put it at the very front just so that when I put it into my calculator, the calculator reads it correctly and doesn't try to multiply 33 times 66 and then take the tangent of whatever that enormous angle would be. So I get 33 times tangent of 66, which is going to be 71.1192135.4. But I want this to the nearest meter. So that would work out to 74 meters. Okay. Therefore, the fishing is 74 meters from the cliff. So it should be good not to smash into the cliff. Okay. So that is it for our problem for right angle triangles. And that's actually it for right angle triangles. For now, what we are going to do on Monday is an in-class assignment about right triangles. And then on Tuesday and Wednesday, we'll get into oblique triangles and then wrap up this unit probably pretty quickly and have a test either late next week or early the following week after Victoria Day weekend. Ooh, long weekend. We might try to squeeze that test in before the long weekend, just so that you guys don't forget everything. Okay. Other than that, I hope you're having a great day and have a great weekend. I'll see you on Monday. Bye-bye.